This new section is entitled the no-choice theorem. What on earth does it mean by the no-choice theorem? Well, if you have two triangles and two angles in one triangle are congruent to two angles on the other triangle, there is no choice but for the third angle to also be equal. If angle 1 corresponds to angle 1 here, and angle 2 and this angle are the same, there's no choice but for those angles x and y to be equal. And the reason is angle 1 plus angle 2 plus angle x is equal to 180 degrees, and angle 1 plus angle 2 plus angle y is equal to 180 degrees. If two quantities, like these two, both equal 180 degrees, well then they equal one another. And if you take away angle 1 and angle 2 from the left side, they'll just be left with angle x equals. If you take away the same from the right side, the equality will still hold, and on minus angle 2. And what's left on the right hand side is just angle y. And they are equal. If you have two triangles and two angles in the first triangle are congruent to two angles in the second triangle, well then the thirds must be equal. It's because the angles always add up to 180 degrees. For example, if you have 20 and 50, and you have 20 and 50. Well, let's just look at the left triangle. There's only one number to put there. It's the number that you add to 70 to get to 180. Well, 0 plus 0 is 0. 7 plus 1 is 8. And an understood 0 plus a 1 is 1. That is, that third angle is 110 degrees. Well, it's not going to be different over here. You add the two angles that you have, you get 70. Well, what do you add to 70 to get to 180? Well, 0 plus 0 is 0. 7 plus 1 is 8, and an understood 0 plus a 1 gives you the 1. The answer is, once again, 110 degrees. There's no choice but for the third angles to be equal or congruent. Now, I want to be very clear. Nobody said these two triangles are congruent. Angle, angle, angle is not congruent to angle, angle, angle. You can have this really, really big triangle, or you can scale it down. You can scale it down. You know what? Angle 1 is equal to 1. Angle 2 and angle 2 are the same. And angle 3 and angle 3 are the same. To make you believe what I'm saying is possible, remember, the sum of the angles, there's no way out of it. It must add up to 180 degrees. Well, you look at a triangle, looks like this. For argument's sake, we'll number the angles this way. And your friend puts the sheet of paper that has this triangle that you just looked at, but puts it under a magnifying glass. And your friend sees this. Now, you might not want to agree this angle is the same as 1, and that angle is the same as number 2, and this angle is the same as number 3. But you have to admit that these 3 angles in that bigger triangle still must add up to 180. And if you think about it, unless you have some funkier magnifying glass, it's not going to make one angle bigger and the other angle smaller. This is going to be angle 1, and this will be angle 2, and this will be angle 3. It's not going to do anything funky when you put it on the magnifying glass. There is no reason why the 2 triangles on the board need to be congruent just because the 3 angles are equal. It's not enough. It's not enough. But nonetheless, we can still talk about the no choice theorem. We can still talk about the no choice theorem. If you come to know that this angle and that angle are the same, and this of a triangle and this angle of a triangle are the same, well then you better conclude, or you have to conclude, that the third angles are congruent as well. Okay, so let's prove a couple of things using the no choice theorem. Suppose you have something like this. Call it A, B, C, D, and you are told that, so this is given, you are told that AB is perpendicular to AC, and that BD is perpendicular to CD. Suppose this is given, and you want to conclude that angle B is congruent to angle C. So statement, reasons. 1, you list the givens. The justification is they're given. Number 2, angle A and angle D are right angles. Number 2, perpendicular lines meet at right angles or form right angles. Perpendicular lines meet at right angles. Now you can say that, you know what? These 2 angles are congruent. Angle A and angle D are in fact congruent because they're both right angles. All right angles are equal to one another. Okay, so we have, basically we have this triangle here and this triangle here. And we want to show that angle B and angle C are equal. Well, we just showed that angle A and angle D are equal. And now, I can label this letter E, and I'll call this angle 1 and this angle 2. And those angles are congruent because they're the opposite angles. If you have 2 straight lines that meet, then this angle and that angle are equal, opposites. And this angle here and this angle here are equal, congruent. Opposite angles are equal. It's number 4, excuse me. Opposite angles are equal to one another. And now I have two triangles, 1 and 2. They both have one pair of congruent angles, and they have a second pair of congruent angles. The third angles have to be equal. Number 5. Angle B is congruent to angle C. Why? The no choice theorem. The no choice theorem. Okay, let's try another one. Okay, suppose you have a triangle like such. A, B, C, and D, E. And you are given the following. CB is perpendicular to AB. And AB is parallel to DE. And angle CDE, angle CDE is equal to 50 degrees. So that angle is 50 degrees, and this is what's given, and you want to find say, the measure of angle A, the measure of angle C, and the measure of, say, one of the angles, CED. Okay. Now, how can you do this? You know that CB is parallel to AB. CB, AB, I meant to say perpendicular, so they meet at right angles. Okay. Now you're told that line AB and line CD are parallel. Well, you could extend line segments if it makes you happier. Here is a transversal. Here are two parallel lines. That's 50 degrees. That's 50 degrees right there. That is 50 degrees. They're corresponding. Okay, they're both in the upper right-hand location. If you have two parallel lines and they're cut by a transversal, you have 4 angles here and 4 angles here. I call that the top right, and that the top left, the bottom right. Well, right here is the top right angle. They must be equal to one another if, in fact, those lines are parallel. And we're given that they are. Okay. Now, at this point, we found the measure of angle A. Well, what is the measure of angle C? Well, just because some y-valve comes along and draws a line through a triangle, that doesn't mean that stuff that you know about the triangle go out the window. This last angle must be 40 degrees, because 90 plus 50 is 140. And what do you add to 140 to get to 180? Well, 0 plus 0 gives me 0. 4 plus 4 gives me 8. And 1 plus nothing gives me 1. So and you don't have to write the 0. The answer is 40. So the measure of angle C is 40. Okay, now let's put back this line, DE. And I know that it is parallel to the line below. And we were given that that was 50. So what is the measure of angle CED, which is this angle right here? And the answer is the measure of angle CED is 90 degrees, because those two, so we have this triangle up here now, and the two angles add up to 90, so the third angle is 90. Basically, you can prove this in general. If you have one pair of parallel lines, perpendicular lines, and then through, say, this line, you draw a parallel one, up there must also be a right angle. Okay, in fact, why don't we try to prove this? Let's try to prove that. It's an important theorem. You have a pair of line segments that are perpendicular, AB and BC. And you are given that AB is perpendicular to CB. And you are also given that DE is parallel to CE. No, to AB. And assume that DE intersects this line. In other words, I can have this line and that line is a perpendicular, and here's a parallel line segment. But no, this line segment does not meet this line at a right angle. It doesn't even meet the line. But if it does, it'll be at a right angle. So assume that they meet. Assume that they meet. Okay, so assuming they meet, conclude that DE is also perpendicular to CB. That is, this too would be a right angle. And how can we do that? Well, believe it or not, one way is to draw a transversal. To do that, draw that line. Okay, now we know that angle X and angle Y are equal. In fact, let's call them both angle X then. We know that those two angles are equal. And we know that this is a right angle. Okay, so what is this angle up there? Well, we know that the measure of angle C plus X plus 90 degrees is equal to 180 degrees. Well, I'm looking at the big triangle ABC. This angle plus this angle plus angle C is 180. Well, basically, take away 90 from both sides, take away X from both sides. 90, take away X. The right-hand side gives you 90 degrees minus X. 180 minus 90 is 90. The other side just gives you the measure of angle C. Okay, so the measure of angle C is 90 minus X. Okay, now let us look at this little triangle, this one up here. the measure of angle E plus x plus 90 minus x. That's angle C. This must equal 180. I can remove the parentheses. So the x's cancel. The measure of angle E plus 90 degrees is 180 degrees. Well, you know that 90 plus 90 is 180, and no other number plus 90 is 180. So the measure of angle E is 90 degrees. That's 90 degrees. Okay, so what we proved is if you have two lines that meet at a right angle, and you have another line that's parallel, say, to this one, and it meets that perpendicular line, it's going to meet it at a right angle. And there's no reason to assume the argument the other way doesn't work. These are two lines, they meet at a right angle. If you have a line parallel to this one, say here, and it meets this line, it's going to meet it at a right angle as well. And there's the proof of such a fact. Never believe anything that your teacher tells you. Nothing. Not saying your teacher is wrong, but don't accept anything that your teacher tells you. Prove it. Okay, prove it. That way, yep, you know it's true. And that's what mathematics is all about. Proving these things. Okay, that's going to complete the section on the no choice theorem.